Hello everyone, today we'll discuss about correlation analysis. You can see this is the outline. There are three agenda points. What is correlation analysis? What are the assumptions of correlation analysis? And we'll consider one example for correlation analysis. Now what is correlation analysis? When we try to find the relationship between two variables, we use correlation analysis. So the use of correlation analysis is to find the relationship between the variables. Correlation analysis provides two pieces of information. The first one is the strength of relationship and second is the direction of relationship. So strength means degree of relationship and directions means in which direction it is going, positive or negative. Then the Karl Pearson's coefficient of correlation. The strength and direction of relationship is calculated by Karl Pearson correlation coefficient. It is denoted by R and it is defined by the formula R is equal to n summation xy minus summation x into summation y divided by under root n summation x square minus summation x whole square into n summation y square minus summation y whole square. So this is the formula through which we find the value of Karl Pearson coefficient of correlation. Now the features of correlation coefficient R is it is unit free. The value of R is lies between -1 to +1. If R is equal to +1, then we say perfect positive linear relationship. If R is equal to -1, then it is perfect negative linear relationship. The closer to -1, the stronger the negative linear relationship. The closer to +1, the stronger the positive linear relationship. If it is closer to 0, the weaker relationship. Now what are the types of correlation? The first you can see the positive correlation. When we will say the positive correlation between two variables, if we increases one variable, other variable also increases, or if we decrease one variable, the other variable also decreases, then it is known as positive correlation. The second, negative correlation. If we increases one variable, the other variable decreases. If we decreases one variable, other variable increases. In such situation, we call it negative correlation. Now the third is no correlation. If we increase or decrease one variable, there is no change on the other variable, then such type of relationship is known as no correlation. Then the assumptions for correlation analysis. The first assumption is related pairs. Data must be collected from related pairs, that is, same participants should provide score of both the variables. So different participants should not be allowed to give the responses for the different variables. Scale of measurement. The data should be in interval or ratio scale. For both the variables, the data should be in interval or ratio scale. So there will be a 4 combinations. So the first variable may be the interval, second also interval, interval ratio, then ratio interval or the ratio ratio. So there will be the 4 combinations of data for both the variables. Then the normality. The scores of each variable should be normally distributed and we'll check it through the Shapiro-Wilk score. That value should be greater than 0.05. You will see it in SPSS. The fourth one is linearity. There must be linear relationship between the variables. For both the variables, the relationship should be linear. Then outliers. There should not be significant outliers. Means there should not be significant, extreme values. So, then the last one is homoscedasticity. The variability in scores for one variable is approximately the same at the levels at other variables. That is, it is concerned with how the scores cluster uniformly around the regression line. So the first two assumptions, that is, you can see here related pairs and scale of measurements, will do it through the theoretical aspect, whereas for the normality, linearity, outliers and homoscedasticity will prove it through SPSS. Now we will consider one topic for this correlation analysis, and our topic is a study of relationship between advertisement expenses and sales of Alpha Private Limited. So this is our topic. On the basis of this topic, we have defined two objectives. The first one is to study the advertisement expenses and sales of Alpha Private Limited, and second, to find the relationship between advertisement expenses and sales of Alpha Private Limited. And on the basis of these two objectives, we formulated our hypothesis. So our first null hypothesis is H naught, there is no significant relationship between advertisement expenses and sales. And alternative hypothesis is H1, there is a significant relationship between advertisement expenses and sales. So on the basis of this, we have to collect our data, and we will analyze the data through SPSS using the statistical test correlation analysis. Now we'll go to our data. So you can see here in SPSS file, we have our data. So these are the two data, advertisement expenses and sales. So our first assumption of correlation analysis was, so the data should be from the related pairs, means we have collected the data from the same company, that is the Alpha Private Limited. So advertisement expenses of Alpha Private Limited and sales of Alpha Private Limited. So it is related pairs. The second is it should be in either interval or ratio scale. So the data are the advertisement expenses or the sales are in ratio scale, because here the absolute zero value is there. There will be no negative value. So it is holding two conditions of correlation analysis. For the remaining four conditions, normality, linearity, outliers and homoscedasticity, we'll do it through SPSS. So now we'll go to analyze, and then we'll go to descriptive statistics, and then we'll go to explore. And in explore, we will advertisement expenses, we will take it to the dependent list, and sales also. And then descriptive statistics, we will click outliers, then continue. And in plots, we will remove this stem and leaf. We'll click histogram, and then normality plots with test. So we'll continue it, and then OK. So this is the output you can see here. From this output, this is our descriptive statistics. From the skewness and kurtosis also you can see here. What is the value of skewness and kurtosis for advertisement expenses? The skewness is 0.402 and this is 0.982. So these values are between, the skewness value is between -1 to +1, and the kurtosis assumption is -2 to +2. So it will be normally distributed. So both these conditions, the value of skewness is between -1 to +1 and kurtosis value is between -2 to +2. So it is holding the condition of normality. And again we'll go for this sales also, it is holding the condition. Skewness is between -1 to +1 and kurtosis is between -2 to +2. So it is holding the conditions of normality. So one aspect from there also we can see the normality. Here test of normality that we have already discussed, Shapiro-Wilk test. From here you can see the significant value, both the significant value for advertisement expenses and sales, both the significant values are greater than 0.05. So the data, both the data are normally distributed. So our data is normally distributed. Histogram value is there. From the QQ plot also you can see all the points are nearer to this line. Some deviation is there, but most of the points are nearer to line. It also shows that it is normally distributed. Then we'll go to the next part. So this is, from here you can see the outliers. This is the box plot for advertisement. So this is the minimum value. This is Q1 quartile 1. This is Q2 means median, Q3 and then maximum value. So there is no point outside this box plot, means there is no outliers. So outliers are not there in advertisement. Similarly we'll go for sales also. Line then normally distributed for sales also you can see here. Most of the points are nearer to this line. So it is normally distributed. Already we have seen in Shapiro-Wilk test also. Then we will see the outliers of sales. So you can see there are no outliers, so no points. If there would have been some outliers, it will be somewhere here outside you will find some value. So there are no points outside. So there is no outliers, there are no extreme values in this data, and then data is normally distributed. So this is the thing. So two assumptions already we have proved here, normality and no outliers. Okay. Now we will go to these graphs. In graphs we will go to chart builders, and then we will select here scatter plots, and we'll drag it here, and then we'll take sales on this axis, advertisement on this, once again advertisement here, and then okay. So you can see here this graph. From here we want to see the normality. So the points, this is the graph. So the points from starting points, it is going towards this. So it is a straight line. It is a straight line. So the relationship between advertisement and sales is linear. So it is not curvilinear. How you will find out is it is curvilinear? If it is going to the middle and it is going towards this x-axis, or from the middle it is going towards the y-axis, then it is making a curve, then you can say that it is a curvilinear. But here our data is going from the left to upward on the right side in a straight line. So our data is forming a linear relationship between the two variables. So there is no curvilinear relationship in our data. So our third assumption also holds, the linearity, outliers, and then normality. Then the last one is the homoscedasticity. For the homoscedasticity, we'll go to our data again. And then we analyze, then go to regression analysis, and then linear. So sales will take it on the dependent and advertisement on the independent. And then we'll go to plots. In plots, we Z residuals will take on the y-axis, y, and the dependent on x. And then continue, and then OK. So we'll not see this is the regression output because we are not doing regression output. So directly we'll go to the chart here. You can see here. So in this chart we will find out. We'll click here. Okay. And then this line you can see. So from the left to right you can see here the deviation of the points. Deviation of the points are almost same, and from this particular line there is some deviations are there, but most of the points are related to this deviation. So the deviations are equal from these particular lines, so it is forming the homoscedasticity. Okay, then our data is holding all the conditions of, or all the assumptions of correlation analysis. Then we can go for the final analysis. We will go to analyze, then correlate, then bivariate, and both the data, our data are on the right hand side. And then here already it is by default the Pearson correlation is selected, then it is a two-tailed test, and then we will do OK. So this is the data you can see here. This is the output. So the correlation coefficient value is between advertisement expenses and sales is 0.874, and it is significant and two-tailed, that is 0.000. So our significant value is 0.000, which is less than 0.05. So the null hypothesis is rejected and alternative hypothesis is accepted. It means there is a relationship between advertisement expenses and sales. Also, the Karl Pearson correlation coefficient value is 0.874, which is nearer to +1. So there is a strong positive relationship between advertisement expenses and sales. What does it mean? It means that if advertisement expenses increases, sales also increases. So how to report this data? So we'll go to here, then reporting of result. So what it is saying? The data collected for analysis holds all the assumptions of correlation. The second, the significant value of correlation analysis is 0.000, which is less than 0.05. So it has sufficient evidence as per decision rule to reject the null hypothesis. Hence H1, that is the alternative hypothesis, is accepted. It means there is a significant relationship between advertisement expenses and sales. The R value of correlation analysis is 0.874, which is closer to 1. So there is a strong positive relationship between advertisement expenses and sales. It means if we increase advertisement expenses, sales also increases. So these are the outputs. Thank you very much. That's all about correlation analysis. Thank you.